Hello, my name's Keith Kreischer. I'm the Executive Director of the IoT M2M Council, and it's my pleasure to welcome you all to Track 3 of our Industrial IoT Summit, presented by the IMC. The topic for this track is IoT backbone integration, and you can see the full schedule in the resources section of your interface. Let me start off by just saying, hey, I hope everyone out there is staying safe and well in these difficult times, and that you're all in the right place. Before we begin, we wanted to cover a few housekeeping items. At the bottom of your screen are multiple widgets that you can use. All the widgets are resizable and movable, so feel free to move them around to get the most out of your desktop space. You can expand your slide area or maximize it to full screen by clicking on the arrows in the top right corner. This webcast is being streamed through your computer, so there is no dial-in number. For the best audio quality, please make sure your computer speakers or headset are turned on and the volume is up so you can hear the presenters. If your slides are delayed, pushing F5 on your keyboard will refresh the page. You can find additional answers to some common technical issues located in the Help widget at the bottom of your screen. An on-demand version of the webcast will be made available later today and can be accessed using the same audience link sent to you earlier. If you have any questions during the webcast, you can submit them through the Q&A widget. The presenters may answer questions at the end of each session, but please feel free to ask questions at any time during the presentations. Any unanswered questions will be responded to offline. I should also note that full biographies for all of our panelists, as well as additional materials, are available at the resources section of this interface. We've got a full panel discussion coming up about backbone integration, but first, just a few words about the IMC for those on the call that may not know us, and I'll keep it brief. The IMC is the largest trade association serving the IoT sector with 25,000 rank and file members. We call them adopter members. IMC adopters are enterprise users, product makers and developers, OEMs, apps developers, smaller SIs, and they come to the IMC to learn about the business case for IoT connectivity. The other level of membership is our sustaining membership, comprised of companies that provide IoT solutions, so connectivity, hardware, and software to connect devices in the field. Our mission is to bring the two groups together to accelerate the adoption of IoT for the public good. We look at today's panel on backbone integration as exactly in keeping with that mission. Once again, I'd like to encourage you all to ask questions at any time during the panel. If we don't get to your question, never fear. The question will be associated with your registration, and our panelists will get back to you after this live event. And with all that, after all that, I'd like to introduce our moderator for the panel, who is Jim Morsch, the principal and founding partner at Transforma Insight. Jim, good morning.
Morning, Keith.
Take us away.
Excellent. I will do that. So thank you, everybody, for joining this session. I'm just going to give a few words of introduction and set some background for this session. I'm going to talk a little about the emerging characteristics of IoT data, because things are changing out there. We've had a history of IoT applications developing, and now we're getting a situation where we're getting much more interactive environments. And I want to go through some of those dynamics of data just as background for the coming panel. Firstly, IoT is it's where the worlds of IT and OT meet. Now, typically, OT, operational technology, those machines that are present in factories and support basic functions and have done for decades. The focus there has been on efficiency, utilization, consistency in terms of the way the machine works, continuity and safety. The IT world, by comparison, has been much more focused on agility and cost reduction and security, speed and business insight. Traditionally, there's been a bit of enablement as some of the information from the OT environment has made it into an IT environment. But what's happening with IoT and industrial IoT is you're getting a much more interactive relationship between the IT world and the OT world. And there's much more data flowing, there's much more analytics are enabled. The interconnect is much more of a challenge in terms of the different protocols and messages and how things work together. Control is an issue and introduces all sorts of security issues as the IT world starts controlling the OT world without a human in the loop. There's a lot more interaction and there's a lot more insight into exactly what's happening in day-to-day operations. So the world is changing as IT and OT meet and as these two evolve together. And some of the particular ways in which they're evolving is we're getting an emerging environment that's very different to the established, more historic environment of M2M as it evolved into IoT. We're now moving. So on the left-hand side is the way the world has been in the world of M2M as it moves to IoT, and on the right-hand side here we've got much more what the IoT world will look like, and that world's developing now. So starting at the top, historically we've had connected devices and associated applications, and that's moving to much more complex applications and data analyses. We've moved from a situation of rigid solution parameters, fixed solution parameters, rigid solution architectures, and speed designed in where necessary to much more heterogeneous and flexible solution components and distributed and federated processing and speed being supported as and when the need emerges. And we're moving from a situation where applications exist in the context of verticals and niches. So a smart metering application just returning a reading from that meter, that data is meaningful in context and it's very structured. And we're moving to a situation where that data is dissociated from source. So you need some richness associated with it, an ontology to say that that is a smart meter reading, which meter it came from, what other meta information it's associated with, and of course some data is semi-structured and unstructured. And more than this, we're going from a situation of predictable growth, because you know how many smart meters there might be in a particular country, to something that's much more unpredictable as the network effects of the exchange of data come into play. And a situation where data ownership is generally clear because it exists within a prescribed system, to a situation where data ownership might often be unclear as that data it takes on its own life in a wider ecosystem associated with its own metadata. So we're moving to a much more interesting world, a much more challenging world, and there are different dynamics associated with that. And that's a little of what we're going to try and unpick on this panel today. So each panelist has a short presentation, and they will present their views on this topic, and then we'll move into a discussion. Anyone out there who's listening to this, please feel free to put questions into the chat box, and if we see them and if there's time and if we can work them in, we'll discuss them in the panel. And if not, as Keith mentioned, we'll take a record and we will get back to you offline. And at that point, I would like to invite Olivier to present some thoughts.
Hey, Jim. Hey, thanks for having me, Jim, and everyone. Thanks for joining this morning. My name is Olivier Bloch. I'm a program manager at Microsoft. I'm looking after our IoT developers and communities engagements. You can find me on Twitter and LinkedIn. I have the chance to host a video show called the IoT Show as well. And what I want to briefly talk about and touch on to add to what Jim just shared is the perspective of an hyperscaler like Microsoft regarding where IoT is at and where we're going and how we want to help and empower everyone out there to thrive in their business, to grow their business, to transform their business by simplifying that part of their business that is becoming more and more prevalent and present, as Jim just mentioned, which is IoT. And we do want to simplify IoT. So before telling you a bit about how we are approaching IoT and how we want to simplify it, I want to set the stage on where we are at today and where we're going, because it's super important to know where we're going to understand the tools we need today, so we can get where we are going faster altogether. Today we are at that stage that Jim described, which is about this intersection of IT and OT to make these assets and our products and solutions more intelligent, connected, more interactive. We're at that very early stage, I would say, of that transformation of this cloud and edge experiences. We will go towards intelligent environments. We're already talking about smart cities, smart buildings, this kind of things. And we are getting there, but we're not there yet, and for many reasons. But this is something that we're looking towards. We have a big campus refresh on at Microsoft in Redmond, in Washington. This campus that will be delivered in a couple of years from now is already equipped with a ton of sensors, and that already accrue to a big, huge digital twins that will allow us to have all that campus to be intelligent, to be interactive. And this is where we're going, but we're talking like 2-3 years. This is emerging technologies. And we're going towards something which is intelligent ecosystems. Put the environments together with the people, with the businesses, with all of that, and now you have these intelligent ecosystems. But that's far away. But we're going to get there. We need to get there pretty fast. But the amount of things that are being transformed in our industries, in our businesses, amounts to a huge amount of challenges as well, especially when it comes to implementing IoT or bridging IoT and OT. And Jim had a really nice list of what are the things that are changing. And all of these present security challenges, complexity to implement, very often lack of technical knowledge and understanding of the different worlds when they clash, I would say, and get together. And in their journey to value, customers are facing that chasm, that challenge. And we see a lot of proof of concept projects that don't even go beyond, a V01 and just stall there. And companies have a hard time realizing the value because things are hard to implement. And this is exactly what we're trying to do. We're trying to simplify things. A typical IoT project architecture would look like that, right? You want to connect your devices in your environment eventually together, or over the air using different networking technologies, and we have Telit and Tardabit people here who will be able to share more about this part. But connect these devices, connect these environments to the cloud, because in the cloud you'll be able to extract the insights from that data that these sensors can share, and then take action, leveraging almost infinite compute, infinite storage for this data. And as important as that left part, which is connecting what I would call the southbound, the devices, the environments to the cloud, you'll need to integrate into your business application, because this is where the value is, the insights, the visualizations, the ability to offer your operator, but also your business people, that view on that data coming from IoT devices. So here we're seeing functionalities, we're seeing things at a pretty high level that definitely imply a level of complexity that is pretty important and deep. And if you take that kind of project at hand saying, hey, okay, cloud and VM in the cloud, I'm going to take care of developing everything, well, you will have a lot of work to get to a point where you have something usable. And this is why we are going towards a model that is higher level, I would say, in terms of programming. And my background is developers, right? So I like to talk about the programming. But here, I'm almost addressing anyone who wants to leverage data from devices. Already today, you can, and I'm mentioning Azure IoT Central for the cloud platform part of things because I work for Microsoft, but our competitors have that, other smaller companies have that. You also have offers hosted on Amazon, on Microsoft, on other cloud providers that will allow you to get to the point where you are able to manage your devices, get the data, analyze it, and then make it available for your workforces. And so think of it at a high level. Solutions on the device side of things are turnkey, almost plug and play. And Telit, Tardabit are a good example of these kind of solutions that will allow you to bridge the world of your environment, of your devices, to the cloud very easily. To the cloud. I didn't say to the Microsoft cloud. Even though we have work in progress with different partners and make that connectivity to Azure as simple as possible, the idea here is to have something that plugs and play into clouds in general. And then leverage a drag and drop type of solution to create a set of dashboards to route the data, to hook up some analytics into that data coming from the devices, to then export the data or some of the insights that have been extracted into simple to develop application. We're talking about no code for triggering workflows. Power Platform is what Microsoft is doing in that space, where you can, with few clicks, without a line of code, create a full mobile or web app, back it up with diagrams and graphics that are interactive, real-time through Power BI, or create workflows with Power Platform Power Automate that allows you to hook up into these business applications. So this is where we are at already, as in we have all the bricks and pieces, and we want to invite everyone to go try them out and not reinvent the wheel underneath, and leverage this level of, I would say, citizen programming that allow you to go fast to business. So I look forward to that conversation today, and I will end it back to you, Jim, to introduce our next panelist.
Thanks very much, Olivier. Now I'd like to hand it on to John from Telit.
Thank you, Jim. Obviously, our topic is backroom integration and how important that is to providing, the data flow, the connectivity that's required at multiple levels to create basically an end-to-end industrial IoT solution. Clearly, Telit has been in this business for many years at many levels. The challenge is always to connect and manage to scale. An IoT solution of one device to get connected and to focus on its specific data is easy. When you get to large scale and scalability, hyperscaler, as Olivier referenced earlier, that is, many of the challenges we face today as we're dealing with this, outpouring of data from shop floors, devices, equipment, and all. If you take a look at kind of the continuum that Telit addresses, it's a pure play IoT framework all the way from sensory level interfaces for sensor and actuation, data cards and modules. That's what many people know Telit as our intelligent connectivity capabilities to manage connectivity for mobility, as well as looking forward into private infrastructures within the manufacturing framework is obviously a very critical strategic path for us as well. And then you get into the types of things that we're going to be talking about specifically focused today, more into the middleware and the platform frameworks that are needed to pull together the connections, from the different devices, as well as, critically upstream to make sure the correct data gets to the correct target in a timely manner so that, there's benefit in what we're doing. The business system is where the value comes into play there, so you can make more timely decisions, and that's what it's all about, is making sure we get that connection made, if you will, as we pull together this tapestry called industrial IoT. And then, of course, the capability to finally, get the data into the application, the business level applications, all of the things that are used to run the business and make decisions. So Telit is very focused on supporting and enabling, this ecosystem end to end. If we take a look at specifically kind of the challenges that we get into when we're looking at, production automation, kind of the OT-IT convergence that we, reference very often. There's critical components at all levels. Down at the actual physical plant floor, you have logic controllers, robotics, conveyor systems, all of those ingredients that make up the componentry to actually produce and to test and to package products for shipment. And you have both automation as well as the operators and constituents that make up that line. The people who have to interact with the systems, the people who have to respond to notifications, alarms, and things of that nature. Upstream, at more of the business systems, they may be on-premise, they may be cloud-based. But all of your different databases, whether it's quality systems, production control systems, OEE, preventive maintenance, all of the types of things that are, part and parcel of delivering an end-to-end production domain. And most of these, I loved it in Jim's opening when he talked about, it's a very heterogeneous and dynamic environment. There are a lot of cooks in the kitchen in most operations, technologies where you have different people making decisions using different solutions, and all of these things have different protocols, different ways in which they need to be integrated in the system, so that in the end, it functions as an orchestra to produce a beautiful symphony. And so it's critical that each one of the pieces come together, whether it's something as basic as visualization or more complex when you get into more supervisory control, but the ability to connect with the protocols that are needed to get that data turned into meaningful information and targeted to the right endpoints, so that business decisions can be made, whether that's on-prem or in cloud. Clearly, the transition to cloud is critical, and we see more and more of that in the larger scale industrial IoT, and Telit, is there to help assist with making those connections. So lots of integration up through, as we're looking at augmented reality activities as well, these things are becoming, practice in manufacturing systems. So the ability to get the right data to the right, target, so that the right individual or the right system can make the next decision in a timely manner is what we're all about from a standpoint of automation. And this is a part of Telit that many people don't realize, that for decades we've been very focused on end-to-end automation. Whether it's, years ago, what we call classic computer-integrated manufacturing, all the way to today's industrial IoT, with all the different components that come together to address that. Looking forward, it's a very interesting, and I don't know, those of us that are in the practice, I think, see this. I know ABI Research and all have talked about the benefit of factory and warehouse, and really, the concept of OT-IT convergence within the Industry 4.0 vision is going to be very important to the bottom line. But an interesting point from Gartner is also that if you take a look at how much data is processed outside of the classic data center environments, that is absolutely growing at an exponential rate. And we see this because more and more devices are connected, more and more devices are communicating in near real time to get data, into the system, so that now better decisions can be made. But along with that comes many challenges: the need for scale, the need for more timely, transaction processing, and of course, what all this comes together to do is effectively accelerate the digitization of our manufacturing frameworks that's needed. So the whole concept of digital transformation was something that has been talked about a lot, but the tools that basically allow you to connect the dots in a very easy, point-click, connect-the-dot manner are going to be critical moving forward. We just don't have the time, for software to be developed from scratch to address all of these things, especially when you've got many of the challenges there at the edge on the plant floor to make sure that the data is ready to go to the targets with the Azures and whatnot upstream. So the ability to do that is critical. At the end of the day, it's still the same types of things we've been focused on for years, as more timely decision-making, improved efficiency, reduction of cost, better quality and safety for the operations. But at the end of the day, I guess the acceleration has caused, additional velocity, increases as we move forward. So the need to be able to connect those dots in as simple and reliable with, a manner as possible is becoming very important as we move forward within the world of the IoT backbone for industrial IoT. But at the end of the day, it's going to pay real benefits. So that's what we want to be able to contribute, and look forward to having the chance to communicate and maybe answer some questions moving forward. Jim, I'll turn it back to you.
Thank you very much, John. And at that point, I'd like to hand it over to another Jim from Tardabit, who's going to give you a complementary perspective, I think.
Hi, Jim. Thank you very much. So Jim Wirt here, CTO at Tardabit. We are a company very focused on LP-WAN integration in this space. So, talk a little bit about kind of where we fit in the ecosystem. If customers have a wired solution, Wi-Fi, high category LTE, there are SDKs and toolkits available from the hyperscalers to go and kind of provide you everything you need to get into the IT infrastructure and the IoT infrastructure. But if you have an LTE Cat-M, narrowband IoT, satellite, LoRa, anything where you care about battery, data consumption, bandwidth, then typically these SDKs don't do what you need, and that's where our Tardabit IoT bridge comes in. We talk all the low power technologies kind of across the board and bridge that into Azure and other ecosystems. And so this is where we fit in the space. Now to talk a little bit about our vision in what we see. we see the rise of IoT was all about kind of the stovepipe vertical platforms. So companies would sell complete turnkey. Hey, here's a device, it comes with connectivity, it has a platform, here's the capabilities of that platform. It provided a great way for the business to grow early, but what we've seen is this is not the way to build world-class leading solutions, because these companies simply can't be everywhere. So what we've seen now is kind of the rise of how do you go and get data from the devices, get it into kind of the IoT mediation layer, and that might be AWS IoT Core, GCP, IoT, Azure IoT Hub, Azure IoT Central, and how do I now get it into those higher value horizontal applications, best-in-class applications? It may come from the hyperscale providers. It may be independent systems. Oh, hey, we use Salesforce as our work order management system and our CRM. Oh, we use Dynamics. We can't even predict all the different systems over the top that people will use to actually visualize and manage their business. But what we can say is the game is not now how to provide a closed vertical application where somebody can log in and see where their trucks are. It's how can we go and actually bring all that data together as a integral part of their business. So, and there's so many different use cases. Oh, we use environmental data from our buildings to report occupancy. We blend that in with the digital twin so that we can have real-time presence. We also track we redirect our HVAC system to only work on the occupied rooms. That's part of our green initiatives. We have our delivery trucks where we're doing route optimization. The use cases are off the charts, and it's no longer about a single consumer of that data. Every aspect of the business wants to consume IoT data in some way, shape, or form, whether it's the InfoSec security group trying to secure a solution, whether it's the finance group trying to do digital tax settlement, whether it's the operations group trying to make sure things get delivered on time, services being met. And as these use cases both converge and diverge, it shows that you really need the industry needs to focus on how to integrate all these different IoT devices, all these different IoT solutions to the applications that customers are already deploying in their backends. Nobody wants a predictive maintenance system just for their little IoT devices over here. Oh, we do water metering. Okay, well, here's my metering app, and then here's my fleet tracking app for my my service vehicles, and here's my insert next application here. And this is where companies like Telit, companies like Tartabit, all help with that feed of data into the infrastructure. People like Microsoft and the Azure platform has a ton of compelling services over the top for customers to build their kind of horizontal application solutions. So, to me, this is a very exciting space, and this is a true sign of maturity that we're able to have conversations like we're going to have today. So with that, I will turn it back over to the other Jim to start our discussion.
Excellent. Thank you very much. Thank you to all three of you for your introductory presentations. John, do you want to come back onto video? There we go. Excellent. We're back. So thank you for those introductory presentations. Just to kick off, you've all seen each other's presentations. Did that trigger any follow-on thoughts for anybody? Does anybody want to comment on some of the things raised in somebody else's presentation before we move forward? Olivia, you're nodding.
Yeah. Actually, this is I had seen the presentation before we were coming today, but I think having them walk through by John and Jim is interesting because it does complement what I was saying about the fact that things are complex and there are different areas of complexity, and we need each of us to provide solutions that tackle this complexity and offer something which is easier to work with, because at the end of the day, what our joint customers are looking for is value. What they want is extract the insights from these things and take action they know their domain, they know their vertical really well. They don't know software. They might not know cloud. They don't know embedded development. They don't know connectivity for devices. And they have two paths: whether they learn everything and hire people to do on their own, or they come and see solutions. And then here they need to find solutions that plug together, that interact together, that are easy to assemble and then to manage. And this is where we're going. I'm convinced, providing these tools at various levels and partnering with other companies to provide these solutions, these Lego blocks, I would say, for creating end-to-end solutions. So yeah, I really enjoyed these presentations because they do confirm that we are all together going in the right direction, I'm sure.
Yes, it's a complex world as you head towards the edge, and the more remote you get and the more constrained it gets, the more complex it is. John, Jim, any additional thoughts? You can feel free if not. But
two things. I mean, Olivier referenced the Lego blocks mindset. I mean, that is so critical to the future in this domain because things are changing so fast, and there's the need for so many more connected devices and controls and whatnot at the edge, that's the only way there's going to be a successful one. And something that Jim Wirt said in his is also the concept that the business side of the solution, many things converge, but some things diverge simply because the nature of the types of decisions and the systems that there are. But the frameworks that we put in place and to end, as part of the overall, ingredient set for this recipe have to be able to address both. So, no, I thought it was an excellent perspective for all four of them.
Okay.
I'll simply chime in here to say I think we answered this one pretty well. So I support my colleagues here on the panel.
Excellent, good, thank you. So starting, I mean, we're talking about integrating data into the backbone, and I take by that core systems or more central systems, and I guess that makes it easier to share data. What do we see the role of the hyperscaler being in this? Starting at the top of the stack, I guess, effectively the furthest from the device. What's the role of the hyperscale industry?
Yeah. So I think, and there's a related question that came in Q&A actually, because part of my answer would definitely address this notion of metaverse and how this data plays into that future world of the metaverse, not the Spider-Man one, but the other ones. And I would like to say that so hyperscalers offer, the scaling. They offer the ability to have infinite compute power, infinite storage at a cost, right? But something that is adapted to your consumption. And at the end of the day, this is something that, we know how to do, we do well, and we have the resources for doing that. And there is the storage part of things, right? And then there is the analytics part of it. The ability for us to distribute the data to conform with the various regulations, the privacy policies as well that are here and there. And so you basically, when you go with AWS, with Microsoft, with GCP, you get that out of the box. You don't have to think too much about that. This is something that we deliver and provide and guarantee for you. So the storage, the location of the data, the analytics as well. There's a notion of adding value by analyzing the data, and the people who would be able to implement the right set or type of analytics might not be software developers. They might not be cloud developers. And so what we provide as well is these different layers that will allow to organize your data, to address your data or access your data, to interact with it, as well as connect AI to your solutions in order to make sense of that data. Jim mentioned predictive maintenance. You need to have models that are trained in the cloud with this compute and these resources I was mentioning earlier on, creating these models, adapting these models on the flight, and then redeploying them to the edge where these analytics will partly happen. And these are things that we provide tools, we provide layers for that to happen in a secure way, in a controlled way. I think this is the main thing here. To Chris's question about how will data play in the futuristic world of the metaverse, I think that this data is crucial. We're talking about a world that evolves towards having connected environments, and then to have these smart environments. And you need to have access to that data from various sources. And the reason why, I think it's important to have different ways of connecting these devices is because, there are different sources. And smart building is a great example of, hey, you're going to have electrical, equipment that sends data through a specific system. And then you're going to have sensor attached to all your watering system. And then you're going to have your heating system that is connected through a different networks with different protocols. You need to compile the data and be able to establish a graph on a model of your smart building that picks the data from all these different sources in real time and offers that through a simple interface to the people who will need to create the dashboards, interact with the dashboards, and so on. And I think our main role is to provide all these tools, all these blocks that will allow customers to develop these solutions and then use them. So this is where I think we're sitting. And in terms of early adopters, yes, like people are already thinking about these models for buildings, models for smart cities, smart grids as well, all of these. And we're already seeing, customers implementing real life solution, leveraging the data that might not be, the fancy HoloLens that, visualizes in 3D the International Space Station and allows you to interact with it, even though we already have a project that shows that. But this is something that is more about, will you be able to interact with your environment through a mobile app really easily and visualizing sensors data on maybe on a 2D screen for now, but interacting with your environments is something that is already work in progress, if not already in production in some solutions. So that's something that we're already seeing out there.
Okay, thank you very much, Olivier. That's a full and informed view on what a hyperscaler does from a leading hyperscaler. Jim, John, from your perspective, which is slightly more rooted in the field and in the collection of that data and feeding it towards the hyperscaler environment, do you have anything to add? What's the role of the hyperscaler from your perspective?
From my perspective, I think clearly from a standpoint of their dynamic and a horizontal expansion, the capability to grow, because it's all about data, right? And it's also just what systems that have classically been considered disparate, but the ability for all of this information or data to be brought together, and then the ability to correlate possible effects of one on the other. I mean, we ran into this many years ago. And something as basic as paint shops in the factory is the ability to start integrating with the HVAC control systems and looking at ambient environmental behaviors and how that affects the quality of the paint, and then the ability to pull these systems together that in the past would have thought, well, we have building automation over here, we have factory automation over there, and we don't know that the two need to meet. But then when you start bringing that information or that data together and start seeing the correlations of it, then all kinds of new levels of quality can be achieved. And I think that's where not necessarily the concept of hyperscaler, just at the cloud and large scale system. That's clearly where it's absolutely critical, and the centralized point where data's coming together for analytics, but also several models to be able to support containerization and the management of containerization down at the edge. That's going to drive additional requirements for hyperscaler behavior as well, because of the ability to have and be able to do the updates, the modifications and all at that level, and then distribute them, effectively as part of the management. I think all of these things drive additional data requirements and all at the hyperscaler level.
Okay.
Yeah, and I'll add on to this and say that when you look why the hyperscalers are so essential. Yes, there are other mega name players in this space. You have the Siemens in the space. You have the SAP in the space. The problem is each of them ultimately comes from their vertical heritage. Okay, SAP is all about ERP at the end of the day. Siemens, it's all about IIoT and the factory and the use case, where the hyperscalers truly still have the horizontal view. So when you look at the future of IoT, saying that IoT is everywhere, whether it's the finance system, whether it's the engineering system, the operations system, the quality system, it all generally touches the hyperscalers, and that can't be said about, let's say, the the non-hyperscale mega clouds. And you know, I know it was a very, I guess I'll use the word humbling experience. I recently did a digital twin integration project, and you know, I was so excited to get our IoT data seamlessly integrating with the customer's twins. But even the twin that represented a device in the field, the actual IoT data was like 10% of the content. Manufacturing data, just the kind of as-built data collection from when the machine was assembled, the finance information about the customer and who bought it and what the service lifetime is, the warranty and parts and all the maintenance history all gets attached to the twin. And well, that's all part of the broader IoT system. It's not part of the actual bits of data flowing between the devices and the cloud. And so, you know, it's been great to see how people are really starting to build out, you know, whether you want to call it the digital twins, the precursor to the metaverse, the amount of data now being assembled and cross-referenced and available to start doing new and kind of powerful views and takes on the space is really you know, I think we're on the verge of kind of the next big turn of something interesting.
Yeah, great. Yeah, definitely. Thank you for that. I agree, and you've touched on something that I was about to come to, in fact, which is, you know, which is these applications or new things that you can do with data that are very much based on sharing data between processes, between players, between organizations, between different parts in the same organization, etc. And picking up on that question from Chris about AR and VR, I think a great example is AR-enabled service out in the field. So a field engineer who has AR-enabled service, you know, they're picking up information from all sorts of locations. Some of the things you mentioned there, Jim, in terms of the digital twin, the device information with IoT input into there. You've got manufacturing data, you've got warranty parts, maintenance history, but also you're bringing in new technical capabilities into that. So it's the metaverse, it's cloud, it's artificial intelligence, all rendered into AR and VR. So there's some really sophisticated, evolved applications coming about. Do you have any other great examples out there? You went through a few in your presentation, Jim. I mean, Olivia, I'm sure you have some pretty interesting examples of converged applications.
Yeah, I want to, there's a term, the term metaverse is something that people are kind of looking at, you know, sometimes just smiling and say, hey, you know, this is just science fiction, or this is just a buzzword, right? And yes, it's a buzzword, right? And it's kind of a accidental that Marvel actually picked it up as well. But what I would like to bring up is the fact that, you know, we very often as technologists, you know, think about the metaverse as this projection of the digital world in your real world with, you know, augmented reality tools, which is just one tiny aspect of it. This is just the visualization science of it. I think digital twins goes way beyond and is already used at levels that are, you know, not below, but that are more at the data level. The follow-up question we had online was like, does Microsoft have a toolkit or a service for digital twins? And the answer is yes. The same way, you know, AWS has one, the same way GCP is working on one. We do, because we do believe that the graph that needs to be created, you know, to put these data sources in relationships, you know, on top of models. So you basically create a model for your building, but then how do you establish relationships between the things that are in your twin, between your various twins at the end of the day? And how then do you query that data in a simple and I would say almost human way? You want to know how many HVAC systems or units are you know, at 50% of their power usage in the building blah on campus Z. You know, this is something that you would query, you know, very simply if you can leverage a graph and an engine that has, you know, the ability to access these models and the graphs and the data in there in a matter of like microseconds or milliseconds, so that you can then render them in a visualization that makes sense for the user. Most of the visualizations will not be augmented or virtual reality. Most of them will be 2D graphs or would be just a number on a diagram, but that number is extracted from a very complex structure, data structure, that you are able to compile and put together. And as a matter of fact, the people will be interacting with or creating these models and then interacting with these graphs are not data scientists. They are not they are operators. And if someone wants to build a graph and say, hey, I want to have, specific information about this series of equipment, at my customers, then they will be able themselves through some simple UI to query that data and extract the insight they need at that moment. And then the interaction or integration with AI is also paramount. How do you foresee the future? The twins will allow you not just to visualize the existing and the current. It allows you to go back in time with time series, but it also allows you to foresee what's going to happen. And by gathering a huge amount of data and implementing Reach AI on top of it, leveraging the compute I was mentioning, then you can start seeing the trends, you can start seeing the future of your twins to adapt your logistic, to adapt your workflows, to enhance your business. So this is where we're going. This is where where technology is at, and I would say already usable today. To the question from Chris, the toolkits, the services are there already.
Okay, John, any particular?
Yes, to add to what Olivier said is very interesting. And when we think of the concept of a digital twin, I mean, when they were kind of born and birthed, a digital twin was basically the context of the current IO states. And then you realize that strategically, as these digital twins have matured, and we're starting to really see them turn into a true life cycle representation of the entities that we're using within the context of metaverse, as it becomes, more and more reality. So I think that's an important thing to realize as well, is that the digital twin is really going to be a feed space, or a reference point for every system in that. And as was mentioned, many of the presentation from the digital twin will simply be 2D, plots and graphs and stuff as part of reports and analytics, but it's still there with that life cycle representation, down to whatever level of detail, that's needed within the infrastructure, within the ecosystem, if you will. So I think that's very important to realize too. It's not just, we run into many customers that perceive that the digital twin is, what's the snapshot of my IO so I can simulate it in an offline manner. And it's like, well, that's kind of the tip of the iceberg. There's so much more to, what is really truly being put into place in the context of an enterprise-grade digital twin.
Okay. Thank you. I mean, Jim, feel free to chip in. I mean, we could talk about digital twins for a long time. They are constantly evolving and really quite complicated. And I know Microsoft focused on it a lot. In fact, I believe you've even written languages or standards or environments for developing digital twins. So this one could go on a while. Jim, if you do have any thoughts, or should we move the discussion on?
No, you can move on to
Up to you.
No, let's continue on.
Okay, so we've spoken about this kind of top level, this kind of cloud level. Now we need to get the information into the cloud, and we're particularly talking about IoT. And both John, particularly Jim, you've gone through the extremely fragmented environment that can be out there, and some quite challenging aspects to getting data in, and diverse data types. Let's focus on. I mean, feel free to add those generic benefits or generic challenges, but let's focus on implementing IoT solutions into brownfield sites, into greenfield sites, situations, and into hybrid situations. So brownfield would be an existing production facility, for example, which has been running for 20 or 30 years, and somehow you want to sensorize that and pull information off that and do things with it. Or a greenfield site could be a completely new factory which has been deployed to the latest technology. And clearly you've got very different challenges there in terms of getting the data off Often it could be new devices out in the field. And of course, you've got to deal with those hybrid environments, which are a mix of new technology and old technology. Do you want to comment? Should we start with Jim? Do you want to comment on some of the particular challenges that you come across in those situations?
Yeah, so, I think, first of all, I don't think I've ever seen a pure greenfield solution. As much as we all would love to someday get into a deal where it's like, hey, this is all new, we can do whatever we want, the world's our oyster. You're always picking up a wide variety of types of assets. And I'll focus on let's say the low power and distributed stuff. I know John should be able to comment a lot more about the kind of in factory and some of the industrial challenges. But when I look at the problems we face today, first of all, we're facing a lot of problems where there's a number of well-established manufacturers out there who all make devices. They've been in the IoT space for years. None of them understand anything about security and modern IT practices. And this is becoming a bigger and bigger challenge as we try to scale out the IoT industry. And, this is where groups like us push hard for a migration to the IoT standards in this space. So, if you're talking metering, asset tracking, container tracking, anything like that, the standard right now is lightweight M2M. Everybody needs to be moving to it. It supports audited security. It supports a rich object model. It's very easy to integrate with all the hyperscale clouds. This type of migration is really holding us back because it's a challenge in the industry. When every new device you get has a new protocol and new quirks, and it makes it a very long integration challenge. And from a brownfield perspective, sometimes there's opportunity. Hey, we have a bunch of old devices. We need to lift and shift them over onto a new IoT solution. Okay, let's get it done. We have a greenfield solution. Let's do a new device, new protocol. But at the end of the day, these solutions sit out in the field for years, and the devices don't actually survive that long on the market, especially now. And one of the things COVID taught us is your supply chain is completely unprotected. So, I talk with people who say, hey, we've been a lifelong customer of vendor X, but vendor X now just gave us a 30-week lead time on our next order, so we had to switch to vendor Y. And these two devices kind of do the same thing. The spec sheets look similar, but they're completely different under the covers. And trying to integrate these in a seamless way up into all those IT systems is a challenge that is no small feat to solve. So that's where the area where we try to focus on the low power side is bringing together all these different devices and making it look like it's one cohesive ecosystem. But I know with what I'll say is, what I'll finish with is there is some convergence coming, and the convergence will really help accelerate the greenfield deployments moving forward. And this is an area where we all need to try to encourage the market to consolidate technology. I'll turn it over to the other panelists.
Absolutely, it's very much a characteristic of the IoT market as it is now. It's fragmentation and constraints. It makes things quite challenging and therefore quite valuable to be able to just pull this data out and converge it and shift it to higher level systems or more core systems. John, any thoughts from you?
Oh, absolutely. I mean, the word brownfield, I think Jim said very nicely, is I don't know, even greenfields many times always have equipment that's coming in there and processes that's coming in from prior concepts and any company's particular deployments for manufacturing. But, one of the biggest challenges we have right now is the aging workforce and people moving out, people that used to operate machinery on plant floors that have been there for 20 and 30 plus years, and they know it's running well because of the way it sounds, or the way it vibrates or whatever. This is just, that's their concept of how to sense it. And clearly, as the workforce is changing, as these machines now need to be integrated into, the part of the formal digital transformation, there are challenges there. I mean, many times you actually have to reach down and physically add electronics, physical sensors and things, digital analog types of signals to pick information up so you can start integrating these legacy pieces of equipment, systems that have served manufacturing well for 25 plus years, but even longer than that in many cases. And now they need to be integrated as part of, context of the digital twin and things of that nature. So it's been, I shouldn't say it is on a weekly basis a challenge as we deal with customers far and wide, that are dealing with these types of equipment where we need to sensorize them, we need to be able to digitize them, and we need to get them, into the overall, framework of our industrial, IoT or Industry 4.0 vision and where we want to go. And it, it really doesn't stop there. I mean, vendors have protocols. In some situations, they're standards. Many times the standards are sub-optimized, but the need to be able to support all the different interfaces that are required in the very heterogeneous manufacturing environment, is all part and parcel of not only a brownfield, but a greenfield as well. Vendors create their products, with their blinders on, looking at how they're going to go into the market and how they're going to compete. And the overall solution to provide a manufacturing line is going to have to take all of these things into account. There's no, silver bullet, that addresses them all. You have to support all these multiplicity of interfaces and protocols to make it work. Yeah. And that's the types of things I think, where, products like Telit brings to the table help to simplify that.
Okay. That's great, thank you. Sorry, we're down to the last 4 minutes, and what I'd like to do at this point is just hand it back to Olivia, because what we've done is we started in the cloud, we've gone down to the remote devices, we've talked about fragmentation and brownfield and different generations of devices, but what that presents back into the cloud is differences in the way that digital twins work. You might have generation 1 of a device, generation 2, they might provide different information, you've got information from so you've got inconsistencies you have to deal with. How do you tackle that?
Yeah, that's interesting, and I wanted to add to the previous discussion something that ties into this conversation, which is things are not silos. As in, this is a devices world and this is a cloud world, and we need to understand that systems are distributed, and even more so these days, and will be more and more. We're talking about protocol translation, identity translation that happens at different levels between the sensor and the cloud. And we need to have a control over these systems, not just the data, right? As in, hey, send me the data, I'll make sense of it, and then we'll resolve everything up in the cloud. But you need to be able, at all the different layers of your network, of your connectivity, of your intelligence, because sometimes you're running AI at the edge or some level of data filtering at the edge, and most of the time, actually. And so you need to be able to understand the fact that it's not, everything there and then everything down up there in terms of data, in terms of control, in terms of security. And this is something that definitely adds to the complexity. Now, to this notion of like moving part, I think it's important that, these systems are more and more tight. Like typically we're talking about, different revs or versions of, a software running on a device or a different, version of a device. So we need to have models that allow to describe a device, describe its capabilities, describe its the type of telemetry, type of commands it receives, and have this model being able to evolve, and so having a versioning of these models for these devices. And there's something we're trying to do by as an extension to our digital twin story is to define a plug-and-play platform for IoT devices. Not in a way of like, defining one standard that will define, all the IoT devices out there and how they should work and so on, but more in the mindset of, there's nothing out there that really ties together, all these different ecosystem, all these different worlds in a way that applications can easily interact with. And so the idea here is to propose around the digital twin the digital twin, languages, propose a way of defining in a somewhat generic way the models for devices, so that when a device comes online, it can declare its model to an application. Application then can say, okay, I know how to interact with you. You're going to send me temperature data that is in centigrades, and so my backend then will know how to deal with that. And this interface, that will be established through these models is something that then can be worked out in the industry with standards and others. And so that's something that we think is permanent. It's really important to make sense of this device's evolution, the replacement of older devices by new one in the same place, right? Your conveyor belts might be updated and have more sensors, but that doesn't mean it's not a conveyor belt anymore. Do you need to rescramble your old factory floor model and application to manage that new conveyor belt? No, you shouldn't have. It should be something that is almost automatic. Hey, new model, new rev of that model because I've got new hardware, new sensor. Here's a new set of data. And then your digital twins in the back end just ingest a new type of data almost automatically because it's like, hey, yeah, new rev. Oh, new set of telemetry. Oh, let me add that graph into my dashboard because there is that new data point that is coming from that device. And we are there already in terms of the technologies and how to put them together. So that's, okay. I don't know if that answers your question, but that's definitely something that I like as a vision for where we are at.
Okay, I think we could keep talking for a very long time on this topic. I think, and it would be very interesting. However, we have run out of time. So at this point, what I'm going to have to do is move on. I'm going to have to say thank you very much to my panelists, Olivier, John, and Jim. Thank you for your contributions, and also introduce the next track. So stay with us for track 4 starting at 11 a.m. EST, which is going to be government policy may help manufacturing sectors. And as soon as this conference closes down, there will be a link and you can click that link and you'll go straight to it. But at this point, I would like to say thank you very much, everyone, for joining. Any questions we didn't get to, we'll get back to you offline. Thank you very much.
Thank you.